Match problem 7 now is going to tie together the different concepts that we've been looking at in this section. We're going to find any critical values. We're going to use those critical values along with a sign chart to identify any potential maximum or minimum values, and then sketch a graph of our function. So we still start off by finding any critical values of f, which means we take the derivative of our given function, which will be 3x squared minus 18x plus 24, and set that equal to 0 and solve for x. So we can factor this expression as 3 times x minus 2 times x minus 4, meaning we'll get zeros if x equals positive 2 or positive 4. So now that we have our critical values, we can identify any maximums or minimums, so maxima or minima, by identifying our two critical values and then choosing test points in those open intervals. In this case, we've got a 0, which is always pretty much the easiest point to choose if we can, 3 and 5. So we would evaluate our derivative function at 0, which would give us positive 24. Evaluate our derivative function at 3, which will give us negative 3. And evaluate our derivative function at 5, which will give us positive 9. So once we have our critical values identified and our sign chart constructed, now we can look at each of these critical values individually and determine whether or not we have an extremum. So in this case, what we have is a function that's increasing up to some point and then changes to decreasing. So that gives us a local maximum. And at x equals 4, we have a function that's decreasing. We hit x equals 4 and it changes to increasing, which means x equals 4 is a local minimum. So once we know the behavior of the graph, where it's increasing, decreasing, if we have maximums or minimums, we can sketch a graph of our function. So we know that we have a maximum at 2 and a minimum at 4. So we want to go ahead and plug those values into the original function to get the corresponding y coordinate. So in this case, 10 and 6. So we'd want to start off by plotting the point 2, 10, and the point 4, 6. So we'd have the point 210, and we'd want the point 4, 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And then we just want to sketch what's happening in between these different values. So we're not looking to get really an exact graph, just to use our sign chart to understand the general behavior. So we know that from negative infinity up to 2, our function is increasing. So it's doing something like that. Again, I'm not being too specific about where we cross the y-axis. I just know that it's increasing. At 2, our function changes to decreasing. Then we hit x equals 4, and our function changes to increasing again. So we could go back, plug the original function into a graphing calculator. The image here isn't going to match up exactly, but we're going to have this general shape or this general behavior of our graph mapped out.